Start. So follow that. So the second part of this morning's presentations are to do with predictive analytics. So you've had the kind of the big picture about what's happening in the marketplace, and also we've had a look at new ways of organising, holding, structuring, and managing data. What we're going to do now is move on to have a look at a number of applications, so more sophisticated applications of data than outright visualization, reporting, and dashboarding, and that kind of thing. So just to be clear, this presentation was put together really with the aim of addressing business people who want to understand what some of the practical implications are of predictive analytics. So really our aim is to help you understand what some of the potential benefits are, to also give you an idea of the range of problems that you can address using data mining, predictive analytics in particular, and then also if you are thinking of undertaking some of this kind of work, then what are some of the things you need to think about in terms of skills that you need, what gaps might you have, how might you cover some of them. So that's what we're looking to cover now. And the way we've organised that really is, so it's again coming back to part of what Les has actually addressed in the part. So why now? Why has this become important now? What's changed in terms of the business context? Because people have always for a long time been using statistical methods. So why now? Why has this come to the forefront now? We're also going to look at the framework that we as a company use for tackling these kinds of problems. And then what we're going to do is we're going to take, so rather than it being based around any particular technology or any particular set of algorithms, the approach we're taking is to say, well, these are some examples of different problem domains and work we've done with other clients. So it's a set of case studies really, and then looking at how things work in practice. So really to start off with the why is this of interest now? I think so. The business context really is that for some of the reasons that Les has already covered in part, so the fact that there's a huge amount more data, that the technology to process that data has come on, and so on and so on. This type of work is becoming much more mainstream, so you don't need to be an absolutely enormous company to have access to the type of capability to store and structure that data or to apply it. So that's one thing. I think so what we're going to look at is a number of examples where we've worked with companies to apply this kind of data, and they're not necessarily huge businesses. So one of the examples we're going to look at is within the last 12 months we worked with an internet business to help them identify some completely new markets that they wanted to get into because of the data that they had stored. Now I don't think that's been a situation that I've come across for that many years, that companies are so seriously trying to look at their data as an asset, potentially to get into completely new markets off the back of it. Another example would be, so we did some discovery work with a large retailer, again based all around data, but trying to look at how they could use that to improve things like in-store availability. But again, the level to which you can assess that down to different store types or different regions or things like that just hasn't really been possible in the past. So the whole number of reasons to why the business context has really changed. I also thought it was worth just saying, well, what do you mean by predictive analytics? Well, it's a means of extracting information from data that you can then use to go on to apply to particular business problems. So looking for relationships, for example, between particular variables. A few things to say about it. It doesn't. The term predictive sounds like it always needs to be about the future, and it isn't necessarily. So it could be that you've got holes in situations that have already happened, or things that you want to know additionally to the data points that you already have. And you can use models to make a probability assessment that says, actually, although we don't have a record for that individual or that particular situation, there's an X% probability that the answer is 1 or 7 or yes or no, whatever it is. It doesn't have to be about the future. It can be about making inference from a lot of data. The way it works is that what you're largely doing is building a model, so building a set of variable relationships based on historical data that you have, data that's known, and then very often we are then saying, well, okay, if this situation arises, how is it likely to turn out? What can we infer from that? So one thing is that the whole approach we're going to be talking about is trying to identify relationships between different variables, whether they're looking at whether they're independent or related. And another thing to say really is that the data itself isn't the only factor in here. So the quality of the thinking and the assumptions that we use to build models as well is also very important. So let's say, I'm imagining lots of people in this room, I mean, we've already heard people like the Met Police are using Predictive, and I know people like Nina in the NHS are as well. But for lots of people, they may well not have done this. So what do you actually need to be able to carry out predictive modelling? Well, you need access to some kind of environment, and that could be a commercial one, or equally it could be open source. So we've mentioned here that there are plenty of commercial options around, but equally use of open source languages like R, for example, has been increasing very significantly. And what we're also then going to think about is what are some of the areas where we apply predictive analytics, and so some of the ones that are very large and well developed in industries as a whole is so customer intimacy. So that tends to be everything around customers. So that can be targeting marketing to acquire customers in the first place. So segmenting them to understand them as groups or as individuals. It can be to do with retention of existing customers, and so not to lose them, not to churn them. It can be to do with growing customers and what's the next best action you might want to apply to a customer at a particular point in time. Optimizing capital deployment, well, so very often there are lots of companies, again, so represented in this room we've got people like Thames Water and others who own a lot of physical assets. So if you imagine how many pumps, how many pipes for sewer network are under the ground, or even this could be an electricity company or someone along those kind of lines, these guys have got, generally what they're very interested in is, by the time one of those things fails and floods your house, or the electricity goes down in a village, for example, or a town, it's too late. What they want to be able to do is, of the many thousands of things that are out there, identify as accurately as they can which ones are likely to fail, and then act before. So often it's thought about as predictive maintenance, and that. So it doesn't have to be maintenance of small items, but it really is to do with predicting within an asset base and then taking action against it. So it's that kind of thing. Detecting and mitigating threats is another big area. Again, so we've got people like the insurance industry represented in the room. I'm sure many of you will be aware of things like the level of cybercrime. Predictive, these kind of modelling techniques are also used for trying to identify, in fact we'll be showing you an example for trying to identify outliers, which were referred to earlier on, which are very often a very good indicator that there might be something a bit fishy about a particular behaviour that's taking place. So there's just some of the examples of sort of the types of scenarios where we use predictive analytics. A little bit about the approach that we certainly take. It's based on there's a process known as a cross-industry standard process for data mining, or CRISP as we'd often refer to it. But Rail's approach is based on that, and it's very well documented. I'd say, if anything, I think we tend to emphasise this top part, which is talking about understanding the business problem. And I think there are people out there that would say to you, today, because of the level of computing power that's available, actually you don't need to start from a business problem. You can actually allow the data to speak to you and tell you what relationships are in there. While I think so certainly when we come on to look at things like segmentation and others, it's right that we allow the data to speak, if you like, but I would honestly say my experience of starting there is that you can waste an awful lot of time and effort. It's much better to have to be clear about what problem it is that you want to look at, because I think what tends to happen is, if you're not careful, you can unearth all sorts of either apparent relationships which just don't mean anything, or relationships that are irrelevant. And in fact, very often, if you start with someone who's a subject matter expert in in that area, they'll say, well, that's bleeding obvious, I knew that already. So it's much better to start off with a business problem, would be our view. And what we're going to cover today is, I've crossed out a couple of areas, because so we're going to look at the how do you arrive at a problem. So how do you go from a business problem into a modelling problem? We're going to think a bit about data, particularly about the relevance for so matching the problem to what you've got, and even if you find that there are things that are missing, what could you do to cover some? So are there proxies? Are there other things that you might find to still enable you to tackle the type of business problem you're interested in? Very often, the majority of the work actually goes in this box I've crossed out here, which is preparing the data. So getting it to the right level of quality, or in the right kind of structure, to be able to model against it. We're conveniently going to ignore that today, largely because it's for this audience it's not that interesting. It can get very technical involved. So what we'll do is we'll skip on to the more sexy stuff, which is actually about then developing models and give you some examples of the ones we've done, and then evaluating those. And then similarly, we're not going to be looking at how you deploy these models in your specific situation and infrastructure and that kind of thing. But that's what we're going to be. So we're going to use this as a framework for the rest of the presentation. So what I mentioned is, so we typically want to start off with a particular business problem, and then look at whether you've got the data to support that. So what I thought might be helpful, and again in a similar spirit to Les's before, where I'd like to hear from you as well, is well, why don't we take a particular example? Why don't we think of a situation? So the situation we're going to think about is an internet loans company. So a company who are where people can go onto their website, apply for a loan, and they'll put in some information about themselves. They'll put in some information about the type of loan that they're interested in, and we're saying that they're interested in growing their business. Okay, so that's the sort of starting point. So what we're interested in is then clarifying the business problem, and then think about what data we might need to support if we want to build one or more models to do with that type of situation. So maybe we can start with saying, so sketchy as that is, so if we think about the business problem, on to the next. Yeah. So what might be some of the things that we might be interested in thinking about if at the moment what we know is saying this is a company you're interested in growing their business. Just checking. So what this is showing is, for example, an individual over here, to try and give you some more context, might go to one of a number of sites. We'd be one of those. What are the kind of things that are behind that red box that might be interested in understanding a bit more about in the business question? Any ideas?
Credit risk.
Credit. Okay. So credit risk of an applicant. Okay.
Size of loans they're interested.
Size of loans that they're interested in. Okay. So these would be potentially kind of data, if you like, these would be data considerations, wouldn't they? Maybe we're starting off with thinking about actually the nature of the business problem itself. Because at the moment what we've said is they want to grow.
Likelihood of conversion.
Okay, conversion likelihood. Okay, so are we interested in, so is conversion an area for us to focus on? So actually that would start to take us into, we're defining a problem that we can then model, because we've got a clear yes or no, if you like, to did someone convert, didn't they convert? Okay, yeah.
Purpose of the loan. What are they going to do?
Okay, so that might the purpose of the loan might well be a consideration.
How big do they want to grow? What's their target as a business? You have to have somewhere to aim for.
Okay, so how big from what base they're going and how big do they want to get to? Okay, yeah.
Availability of funds.
Right. Okay. So potentially, is there a limit to the funds that they've got? Maybe things as well like is there a particular risk profile that they might want to get a particular mix of risk in there and things like that.
Will the loans meet regulatory requirements as well? Be able to breach FCA regulations?
So if there are any compliance issues, those kind of things. Okay. So there's a few things in there. So typically, the kind of things, if we're starting to try and get to the point of a problem we can model. If someone said that they're interested in growing, the kind of things that we'll be interested in to try and arrive at a problem that we can tackle through modelling is say, well, exactly what does that mean? So if growth looks like, or if success for you looks like you've taken on someone's successfully taken on a loan that they wanted, is it that you want to get, so are you interested in getting more people into your funnel in the first place, attracting more people to your website? Or are you interested in things like the people who are already there, converting more of them? So how many people who are applying are actually going through to successfully get a loan, for example? We already mentioned about things like, is an optimized mix? So maybe, for example, you want a mixture of certain loan lengths, an amount of funds that's available, a mixture of risk, and so on. So these are some of the kind of questions that we want to try and pin down, because growth is too vague at that stage. We're trying to get something that we can then define, set a target for, typically, and then say, okay, what might influence that? What data do we need to support it? So maybe going to go one step further. So what we touched on this a bit already. What are some of the types of things we might want to know about the data, or what type of data might we want to try and find out about? Any ideas?
Can we tell from the data the loans that weren't successful, and what would the profit be if they had been? And what do we say, for not actually accepting those people?
Okay, so this is people who've gone through, they've made an application,
But failed because of, credit risk or
sort of failed for some reason, either because they were rejected or potentially they turned it
So
down.
what's the difference between the profit that they've got an interest to what they've lost because of the risk factor?
Right, certainly. So we're interested in, so for example, do they look different? Do people who apply and then were successfully converted, do they look different in some way from people who applied and then didn't convert, either because they were rejected or maybe those kind of people keep turning us down? Yes. Anything else? Okay, we've got some. So some of the kind of things might be we might be interested in things like, well, are there some things we can see about, because given we said that this is an internet company, do they behave in a particular way on the website? So another company we worked with who were an internet retailer. What we found in their case was that so again they're very interested in conversion, and actually what we found was that a strong indicator in their case that someone was going to convert was how quickly they went to a specific product page. Right? So if they went directly to a product page, so this was a gift company, right? So if someone came onto their website directly to that particular product, there was a good likelihood that they were going to convert, rather than someone who's browsing around at a fairly high level on the website, for example, we found in their case was much less likely to convert. So in this case, actually, so coming back to what's the business problem to tackle, have we got data to support it? Actually, we didn't have any behavioural data about what people were doing on the website. What we did, what was of interest, or one thing that was of interest that was available, was actually all then to do with they were providing certain information about so the loan and also about themselves, and there were different stages in that process. And the reason we've shown this as an arrow here is depending on how much information they provided and how much detail the loan went into. We've also got more to go on as regards developing some kind of model. But can you see that what tends to happen is you start off with a vague business problem, you define it, you try and come up with something that you think you can model. Then there's a reality check, which is actually what data have you got. There's some big areas of data you've got, like even things like source of lead, for example. And it's quite difficult to go further back up the stream and add people into the funnel. But potentially what we can look at here, because this is actual people who are already on the website, is conversion. See, so we looked at a whole number of different potentials. We won't go through these now, but the main point is there's a definite process that we can follow together, which helps us then pin down, right, this is a good fit for you. It's going to meet your business objectives. There is some, we think it's going to have some data that's worth looking at. Let's start there and picking something quite specific to go after. Yeah, so so what we've done so far is we focused on getting to a particular business problem. And what we're now going to look at, say, convenient, we'll skip over the whole data stage. Then we're going to look at a number of real examples of where we develop models for clients. And so we're going to start off again around one which is so in the customer intimacy space. Remember I said customer intimacy, assets, and so on. So, and again, so this is continuing from the example we've just been looking at. So what we ended up saying was, okay, we don't have this on this upstream data, but actually we do know that 23% of people who came onto this website went on to make an application. Well, if that's the case, what can we do about those people? Can we get the conversion rate up for those people, the people that we know who are making an application? And one way of going about that is then to say, well, rather than just looking at them as an amorphous blob, can we actually find out a bit more about them? Are there particular groups of people, in terms of perhaps their own characteristics or things to do with the loans, that would help us target them better? And the approach we take to that is using cluster analysis. What this is showing down here just on the right hand side is this is a screenshot from SPSS Modeler, and this is the output from developing a particular model. And what this is showing is that of these people who were in here, we identified a number of clusters. Usually a good number is kind of a handful. So you don't want to be getting up to, if you can avoid it really, 25 or 30 clusters because the groups are too small, it's too much work for you. What you're really trying to do is get a handful of good sizable clusters of people that are similar enough that you can then target those people and then go on to look at more accurately. So I'll go into the next slide. What we've done is we've picked one of those clusters out, and we've said, well, actually 23% on average of people who were making applications for this particular cluster, actually the rate was 53%. Now they're of considerable interest to us then. So if we get someone coming onto our website who looks like this type of individual, then we should be very interested in them, because there's a good likelihood that they're going to go on and convert. And so the kind of thing, or at least make an application. So we're then also very interested in, well, did they go on to successfully convert? Did they actually go on and take out a loan? And if they didn't, why was that? Was it that they were rejected? Was it that they said they didn't take up the loan? Could it be that there's a product opportunity that if maybe they're not being well served as a segment? So that's the kind of process that we're going through. I just wanted to come back as well to something that Les said earlier on to do with and also think about what kind of skills do you need. And I thought I might show you here that the way that this works, certainly within Modeler. So what this is showing, this is actually a screenshot taken from within the tool, and all the yellow on the left-hand side is actually sourcing the data out of a set of databases, checking it, and then carrying out all the data preparation processes to get it into a state that we can then model. So these yellow things over here are a number of developed models based on the data. And there's all sorts you can see. So one, in fact, actually, this star, or when you see star, there's even more detail behind it. So quite quickly you can end up with a really because you're doing this iteratively and you're going through a discovery process, you can end up with quite a complex set of steps. So if you're just doing that in code, it can get really quite tricky. We certainly find it very helpful to have a visual way of working, and the fact we've ended up with so many models over here, we didn't know how at the start which ones were going to work. So what you can see is there are a number that are cut off, and that's typically because we've tried something out. Let's get the results for later, or maybe we were just saying that, well, that didn't work on that occasion. Let's try a different approach. So the green stuff on the right hand side is actually the modelling step. Another benefit of this kind of approach is also that you can share it. So if you've got a team, let's say you've got a team of 5 people, and there's an area you say, well, this might be of interest to us. We're going to have a look at conversion as an area for our business. If what happens is you start to find some very promising results, well, number one, you're working within a structured approach, and there's a recognised set of steps that you've got which are common between people. But secondly, this kind of software, you can actually take a copy of all the work that's been done at that moment and make it available to them, or in fact, or hold it in a central repository and multiple people can work on it. So it makes it a lot easier than if you're handwriting code and that kind of thing. At this point, I'm going to hand over to John, who's going to come up and talk about an example in the customer intimacy space again, but with a different client.
So this is a client I think we've all heard of, Royal Mail. Is anybody from Royal Mail here today? Okay. As Jefferson mentioned, that broadly speaking, when we're doing this kind of analysis, when we're modelling, we've got two types of entity. We're either looking at people, or we're looking at infrastructure, machines and things. So we're going to focus on the first side, which is looking at people, and particularly looking at the customer type. So we could be talking about patients, we could be talking about citizens and so on. And the way we often think about the different types of data that can go into the mix to build these models is in these four areas really, and you can think of them as sort of partly traditional and partly some of the new data that Les was talking about earlier. So traditional data is really the data about the people, so it's whatever we have in our customer data, usually where we've got registered information and self-declared stuff, along with some sort of third-party information you get from geodemographics, and people like Experian and CSEI and so on. The voluminous data, and this is the example in Royal Mail's case, is often the behavioural data, which often starts off in some sort of operational transactional form. So in this case, we're talking about data that came out of web analytics, which was right down to the individual click level. But this is looking at anything we have that captures what customers did, which often is the core stream for the prediction of what they're going to do next. Behavioural data is the strongest predictor of future behaviour, which is enriched by all the other stuff. And then back to what we talked about earlier with big data, there's then the how do they do it? You know, what are the devices that they're using? What are the channels that they're using? Various formats of contact usually, of touch points, in a sense of what you might think of as the digital behavioural signals that exist. And then finally, something else that can come from social media, so we can pick up sentiment from social media. Sometimes it comes from primary research or secondary research. This is more about what they think and how satisfied they are and how loyal they're going to be, and so on and so forth. So you can think of those as having four specific purposes. The first one tells us who the people are. The second behavioural silo tells us what it is that they do. The interaction data tells us how they do it, and the attitudinal data tells us why. Now I have to be honest and say very often this is the hardest stuff to get to, and often we'll build very good behavioural models that can predict behaviour but not necessarily explain it, although we can hypothesize and take hunches. We built some models recently for an airline company who had a particular behaviour where customers would get to the top tier of the loyalty scheme and disappear. So we could build a very good model to predict who's going to do that when they get to the top of the tree. Some do, some don't, but we couldn't explain why they did that. So we actually took some primary research to actually unpick that in the end. And one of the reasons is that they go on and try and get to the top tier of another loyalty scheme, so there's a kind of competitive thing going on there. So in the case of Royal Mail, back to Jefferson's explanation of the framework, we always start with business objectives, discussions with stakeholders and business owners. And in the case of, and we kind of executed this kind of project for a number of website owners where there's actually a fundamental question around who comes to the website and why do they come to the website. And we're trying to get to that real understanding of essentially the core segments of visitors to the site. And obviously the reason we want to do that is to make the site work better for those visitors. So we want to construct customer journeys and information architectures that actually match what the customers want. We can extend that into making recommendations, product offers, marketing and so on. But essentially by understanding who they are, we can predict what they need next and what their requirements actually are. So another way to look at that framework, we talked about the who, which is the description of the visitors or the customers to the site. We talked about the why, which is what they come to do on a particular visit, or generally speaking, what do they do across a number of visits. And then there's the what they actually do when they get there. So the key thing here is to be able to link those things together in one form or another. And sometimes that's easy to do because we have IDs, and we can link cookie information, and sometimes we can pass URLs around with query parameters on and so on, and sometimes it's more fuzzy in terms of the way that we end up matching. But when we do this, what it gives us fundamentally is a set of customer types, a set of customer segments that can be described and profiled by behaviors, their attitudes, their intentions, and fundamentally who they actually are, what type of people they are. So an example from the Royal Mail project was a particular segment who came to just track and trace, essentially, which is one of the functional areas on the Royal Mail site. They didn't come very often. They tended to be slightly older, and according to the satisfaction that we managed to derive, they tended to be happy. So the site was actually performing for them. So that was a good example of the site in its current form doing what we needed it to do. But in order to get to that information, we have to do some heavy lifting. So we have to start with that core clickstream behavioral data. And what that usually means is taking data out of the web analytics platforms that exist, like Web Trends, Adobe, Google Analytics, or whatever it happens to be, at the raw level, so at the clickstream level. So in the case of Royal Mail, we took 6 months worth of clickstream data, which is clearly in that realm of the sort of big data that we're talking about before, and we effectively roll it up, aggregate it, reconstitute it to look at behaviors across visits and within visits. So we build, this is where the data mining comes in, we build models that actually group together behavioral types into segments. We then layer on top of it the other stuff, so whatever we can get from the customer databases or for any surveys that we can run a kind of agile way online, try and understand what they're there to do, how well the site serves them, and any demographic information that we can pick up along the way. So here's an overview of the segments that we ended up with, and you always sit down with the business owners and come up with names that try and characterize them in a way that's meaningful to the business, and you get buy-in to them, and sometimes the names are a little bit corny, I have to admit. One thing, I don't know if has anybody done segmentation of clickstream data before? Anybody in the room? 2 people. You often find, of course, a lot of it is very low level, not much happening. So the idea of the one-hit wonders, which could be about cookie deletion behavior, it could be about people using different devices, and so on. So there's a choice there about actually, do we focus on visit behavior, which of course we can characterize anyway, whether we see them again or not, or do we try and capture the visitor, which is what we did in this particular case. And then once you've got the core segments, if they're doing their job, then they pull apart on other characteristics, and they have predictive power. So they'll have different levels of value, they'll have different levels of engagement, behavior, satisfaction, loyalty, and so on. And those are all the things that you can then act upon and do things with. Another way to look at it is about value. This is actually an example from a media site where we profiled according to effectively potential advertising revenue. And what you often find is a particular segment, which was like 9% of the visitors to the site that had an exceptionally high value. You often find at least 1 or 2 segments that the brand owner is totally unaware of. They don't know that segment exists. This was actually a segment that they went off and launched an acquisition campaign around in the Sunday newspaper, because they were a particularly affluent segment visiting the important ad revenue generating parts of the site. So what I'm going to do is I'm going to do a short demonstration using SPSS Modeler, which is the software that Jefferson just referenced. Master technology. To illustrate how we actually go about doing this, and I'm going to take, in a sense, a simpler example where I'm going to make a very clear prediction. So this is, let me just run this data to a data view so we can get a view of it. This is actually magazine subscriber data. If I run it through to the table, you'll see we've got about 103,000 records and a number of different characteristics, which again cover some of those behavioural characteristics and demographic characteristics about the subscriber themselves. Now I'm going to cut to the chase because I think as Jefferson mentioned, often we spend a lot of time, and you saw that stream earlier with the yellow area, getting the data in the right shape to perform the analysis. So one thing we often do is construct time windows. We'll look at historically what happened up to a point in time and then what happened next, so that we can then sort of take that model and roll it forward to make a kind of forward-looking prediction. The business objective here is to identify or to create a propensity score, a prediction for how likely each individual subscriber is to renew at the next renewal day. If we look at the distribution of, connect that to that, we can look at the distribution of that retention rate by just looking at this renewal status that we've got here. So we're looking over a period of time, looking at 100,000 subscribers, but in this particular example, it's roughly 50-50. We've got about 41%, we've got about 41% who renewed over that period, and 59% who didn't. So what I want to do is cut to the center, the core of the process that we use to build a model, which is to do a couple of things. The first thing we do is we describe the model. Using the touchpad, which is let's use the mouse, I just realized. We actually describe the model. Remember, the business objective is to predict churn, to ascribe every subscriber with a churn propensity. So we make that the target of the prediction. And then what we do is we decide which of the other characteristics, behavioural, demographic, and so on, are potential predictors of that target. Now, there are two ways to go at this. You can either use good old hypothesis-led descriptions. You can actually say, look, these are the top 10 things that I think are going to drive it, or you can be more data-led and say, actually, I want to put more things into the model and see what the model tells me is the other top predictors. I'm going to turn off the ID, and I don't think I've got it here. Sometimes you have other variables or fields that are directly related or correlated to. You just need to make sure this is turned off. But I'm going to keep more or less everything on here. I've probably got 15 or 16 different potential predictors. We could have hundreds, we could have thousands. Often when we're dealing telco churn, we start with about 900 and so many. Now the other key thing we do, in the middle of the model that Jefferson showed you, we talk about testing, modelling and evaluating. Now, we have to decide, and this is something else we do in business understanding, what good looks like. So by this stage, we know what a good model would be in terms of the accuracy that we're aiming for. How well do we need to be able to predict whether somebody stays or goes? And or, what is the kind of financial simulation around that? If I retain an extra 10% and they stay for another year, what does that equate to in average? So it can be as sophisticated as financial modelling around how good the model is, or it can be as simple as I want it to be 80% accurate or something more direct. And in order to test that, somebody mentioned control, from the Met Police, you mentioned control and test earlier. Of course, once you put this model into the field, ideally that's what you would do. But essentially you do this at this stage. So we create a holdout and say, okay, here's 70% of the subscribers that we give to the model, we'll keep 30% of them back. So I'm going to set a 70-30 split. And it's how well the model does in that 30% that tells us really how good the model is, because that's more like what will happen when we put the model out into the field and then the reality of that situation. Now at this stage, we have to decide on an algorithm. So the whole core of what the predictive modelling, data mining is about, advanced analytics, is the ability to look at large numbers of fields and build models that find the relationship between those and the target when we're making a prediction. So I'm not going to go through all the specificity around the models. The good news is, I wouldn't say that models are becoming commoditized, but it's less and less about finding or really understanding in depth a particular algorithm. It's really about testing and evaluating. Les mentioned Spark earlier. The other product direction, if you like, of SPSS Modeler is to be able to add in algorithms from anywhere. Whether those algorithms reside in the database, which might be in a teaser or Oracle or DB2 or SQL Server, or whether they sit in big data. So whether we're talking about Spark machine learning or Azure machine learning, those will become extensions. In fact, Spark is in the new release, which is out any time now. So we can run models on big data from this particular data view.
Do you want to mention the R extension?
And there is R, yes, of course.
So if you're a big R user, you can access the...
Yeah, and that's really the first sort of incarnation of what we just described, which is R. How many people use R, know of R? Pretty much everybody. So R, for those people who don't, is open source. It's an open source statistical data mining platform. So in our world, it's sort of our equivalent of Hadoop, because that's where you can go and pick up algorithms for free. So you can run those algorithms directly from within a commercial model stream. Without going into sort of too much of it, the other thing that we're seeing bubbling up is a kind of pyramid usage, where you have kind of hardcore data scientists creating our packages and broader business analysts then using tools like Modeler to actually use those assets to build their own analytical streams. I'm going to pick a decision tree. I'm just going to go back to the beginning here. Pick Chade model. How many people have heard of Chade? So Chade there are essentially three types of algorithm that we have. There are statistical algorithms, and many of us will know those from different times in our lives or our school lives, things like regressions. There are decision trees like Chade, which will generate rule sets for us. And then there are pure machine learning algorithms like neural networks that are more black box, but can sometimes be very powerful in terms of their kind of predictive capability. What a decision tree tells us is two things. First of all, it tells us what it thinks the best predictors are, and actually, top of the tree comes lifetime value, how many times they've renewed before, but then things that are more pertinent and recent about their last payment value and so on. So there's a subject matter process that happens here to validate what the model tells us. We might decide actually lifetime value is too direct. We want to build a model that doesn't have that in, because that we can use it in a more operational way to do that. The next thing we'll do, and the final thing I'll do with this model, is evaluate how accurate it is. So I can, for example, connect evaluation to it. And produce one form of curve or another. Now remember, we did the 70-30 split a little while ago. So this is how well the model performs on the 70%, this is how well it performs on the 30%. 30% is other subscribers it didn't see. And of course what you're looking for is that the curve isn't much flatter over here than it is here, because this is one of the ways that we can look at accuracy. So what this curve is telling us, in the top 20% of predictions of churn or renewal, then we're actually predicting 50% of those customers who go on to renewal. So it's a hit rate of 2.5 to 1, and sometimes that's how we talk about it as a kind of lift metric. How much better than random chance is the model? So from there, and obviously I'm not going to kind of elaborate too much, but we would either have hit our success criteria that we defined in the business business understanding at the beginning, or we need to keep modelling. The reality usually is we need to keep modelling. We need to try different models. Sometimes we can have multiple models working together, try different algorithms and so on. So that's typically the process that we go through. Once we're happy, we have, so the yellow nodes are the generated models, the nuggets. Once we have the best model that we can generate in the time that we've got, we can literally take that and plug that into another data source, which may be coming from a relational structure, Hadoop, often simple text files or other operational systems, and that will effectively then score each subscriber into the future. So it will give us a propensity score for every subscriber based on their likelihood to renew at the next renewal point, in this particular example. Any questions about that? Okay. Final thing I say, sorry, just back to Les's point, all of that is SQL behind the scenes. So under the hood, that's all rendered as SQL, which can effectively run inside any platform that understands SQL and can effectively consume SQL.
Okay, I'm going to hand back to
Yeah, thank you.
Jefferson for the next one.
That's great, thank you. So the purpose of that was really for particularly if anyone hasn't, again, we're trying to cover, so there are those of you in the room who are experts in this area, and others I'm imagining who haven't tried anything like this before. And so so the aim of that was really to give you some idea at least as to what are the kind of things you can do, how can you go about it, and so on. The next example relates to capital deployment, actually, so optimising capital deployment. So a number of, I'd say lots of companies struggle with exactly where they should invest. I'm sure that's not an uncommon problem for many of you. How do you make those decisions? Well, of course, that's very often the role of key performance metrics in organisations. This is an example from a regulated industry where the regulator, one of the metrics that the regulator uses to judge this type of organisation is a customer satisfaction measure based on the interaction of a customer with that organisation, and they get asked a certain set of questions, one of which is an overall customer satisfaction score. And what happened at the time was that there was a desire to improve the customer satisfaction score. This would equally apply if you use Net Promoter Score, for example, one of a number of other measures. And at the point at which we came in to have a look at the data, one of the senior managers in the organisation was getting a lot of pressure from the board, and what was happening was that literally every week they were either getting a pat on the back or a kick at the backside, depending on what the customer satisfaction scores were for the previous week, and it was causing a lot of heat. So one of the things we wanted to look at was, from a statistical point of view, actually are the variations even significant to start with? Because if they're not, let's give the guys some space and let's work out what is really relevant. So that was one of the starting points. And they also said, look, we're like most organisations, we've not just got unlimited money. If we want to improve our CSAT score, what's the best way for us to go and do that? Can you help us identify what are some of the linkages between internal business processes and the impact that's having externally on our customer relationships? So that's kind of what we were asked to look at. So the first thing we did was actually so this is looking over a period of time across the bottom here, and then this is looking at the average customer satisfaction score over that period, and the round blobs are where the average figure was, and then these are showing the error bars on so to 95% confidence. Does this sit there, or potentially it could sit somewhere between the two extremes of the line? And one thing we're able to say quite quickly was actually there's virtually no difference. So whether you're celebrating with this guy and opening the champagne, or telling him he's sending his P45 in a 2-week period, actually just need to give the guy some space to start with. Now, what we did start to do was have a look over a longer period, and that actually presented quite a different picture. So some of the older figures, there was a lot less accuracy in. But if you imagine the starting point was, they were just seeing these kind of central blobs here. And what we did pick up on was say, actually, did something significant happen at this point? Because actually, it looks to us like something significant did happen at that point. And in fact, that time corresponded to some major changes that they made in their call centre. So these are things that you can do quite quickly to make sense of the numbers, to stop organisations drowning in the data, start making some sensible decisions, and also things like picking up on that does look significant to us. Just helps in terms of providing some believability that there is actually a connection between what you're seeing in the data and real business events that people can relate to. So we then said, okay, well, let's start and have a look at some of the internal processes. I'm not expecting you to understand the detail of this, but the point is what we done was we said, let's have a look at how these break down by different process area. So what is it which part of your organisation has that customer actually interacted with, and therefore what is it that's likely to have had that effect on them, high or low score? So that's looking at these figures down here. all that's happening over here is we're then trying to normalise, because you can imagine lots of people bring a contact centre, and perhaps far fewer people have someone, in this case, who come out to their house and do some work. So we need to allow for that, then, in terms of, well, how many low or high scores are we getting? What would we expect based on the size? And then on that basis, we said actually there are a certain particular of their business processes that we think is worth starting with, because it looks to us like that's where most of the problematic. So in their case, they particularly asked us to look at, it's on a 1 to 5 scale. 1's the worst, 5's the best. And they said actually we're really interested in 1s because they get a lot of attention, and we'd really like to get rid of the number of 1s. So we said, okay, well, let's have a look at how the 1s break down, and that directed to a degree how we went about it. So after some sort of reallocation, we said, okay, we were aware there was quite a lot of activity around the telephone area anyway, but we said actually let's look at the requests we get. This was a water example. So these are requests for people getting a new clean water connection. Let's have a look at the process that relates to that. And so that's been driven by, again, coming back to the aim of saying we want to improve our customer satisfaction score. And at this point we said this is significant, this is not. This is now, we've narrowed down to one business process area to say, out of everything that's in there, let's start here, because that looks like it's going to potentially have the biggest impact. This is just then looking at the sort of starting data that they had, and we said, okay, well, one of the things we were direct about actually was saying we'd be really interested to understand what we think waiting time has an impact and is quite significant for each individual. Now, so coming back to the question where we came from earlier about data availability and matching to your business problem, we said, great, yes please, we'd like to understand how long people have been waiting. Well, the answer is we couldn't get at that data at the time. It wasn't an easy thing to get access to. So very often when we're modelling, one of the things we think about is, well, is there something else that might do instead, that might be a good indicator of the same thing, if we can't just lay our hands on that exact thing. Well, now this is more summarised data, but what we can see is things like the orange line here, this is by week, is actually how many jobs in that particular process were outstanding at the time. So it's probably not an unfair thing to think, well, if you've got a big queue, people are probably waiting longer than if at another time the queue's smaller, people are probably waiting less. See what I mean? So although we've not got the full level of detail and data we need, we're saying, well, that's probably a good indicator. Let's start there and let's see what we can see in there. So then again, using the type of modelling that we've been talking about, sort of looking at some statistical significance measures, what we started to look at was we looked at a 40-week period, and we looked at the responses that we were seeing versus queue size, and we said, well, actually, there's probably a time lag, isn't there, between so potentially you get sent a request to provide feedback. Do you provide that instantaneously? Well, maybe not. Maybe there's a time lag. So we then looked at, well, let's see how it compares against the current week of queue size, put a 1 week lag in and a 2 week lag, and let's see what we can see. And what this is showing is that this is a particular correlation assessment. The ones that are marked with a star are saying that at the 95% confidence level, that there's a significant relationship. In other words, that's saying it looks to us like so the queue size has a significant effect, and so actually what we're really interested in is looking at, well, what's the impact when we go back to how long people are actually waiting. Another reason this is worth doing, because again, this is what we're all constantly trying to do, is do things that are easy, to find something that's significant, to then potentially justify, well, if it looks like it, then it looks worth doing, then let's spend a bit more on doing it more properly. And that's actually what happened next. We then did get hold of the detailed data, proved that there was a significant relationship, and then that of course then led on to decisions about, in this case, it's to do with staffing. So it's not even that you're going to have to spend a lot of money on investing on something heavy. This is actually helping you direct where you're putting your staffing levels within your company to achieve the optimised customer satisfaction score, if you like. So that's just, quite a different example from the one John showed you, but it's just again to try and give an illustration as to how these things can work in practice. You can see whatever, so you can target a particular type of performance improvement that you want in your business, and then work backwards from that using data and make good decisions based on it. One other one, that, again, similar type of industry, I happen to think this is really interesting example, is flood risk analysis. So predicting where you're likely to get, or which areas are likely to flood. What this is actually a diagram is showing the output at a particular level of aggregation of predicted risk for flooding over particular areas. So I'm just going to go back a little bit and say, so again, the way we went about this was to say, obviously the idea is you want to minimise flood risk, and in this case there were lots of different types of flooding that can happen, and they're managed differently. So lots of rain comes down, there's not a lot you can do about that necessarily, but whereas if you're looking at things like sewers getting blocked up, or sewers or pipes breaking, if we can foresee that happening, then we can do something about it beforehand and prevent people's. I mean, it's terrible, isn't it, if your house gets flooded? So some of the thinking you go through again is starting from the problem and then saying, well, what kind of things might be influential in flooding? And again, I think what really came out in this example was it was well worth having really knowledgeable business people in the room. One of the things that I've mentioned this to people before. One of the things that came out as a possible risk factor, and we included it in our model, and it was very significant, was the land usage type, and in particular where fast food outlets are. And so if you think that through, part of the reason is that so if you've got a Chinese or an Indian or a fish and chip shop or whatever, probably an awful lot of fat that goes down from their premises into the sewer and can swirl quite a long way down the pipes and gradually over time block them up. So it's just trying to indicate that I think very often you can save a lot of time and arrive at some salient data sets if you work carefully on what your business problem is to start with and include the right people sort of in the room at the start. And again, so this is the kind of the outcome. We always had decisions to make about what level to model at. So in practice, if you know that somewhere in the City of London there's going to be a flood, that's not much use to you, is it? This one can actually go down into more detail. But at least you can get an idea from it as to what this model's predicting as a forward-looking, either increasing or decreasing risk likelihood in a particular area, and then you can actively send people out looking, in this case, lifting the manhole covers, going down and looking in the pipes before anyone's actually reported that they've got problems. There you go. I think final area we're going to cover, I think, in this section this morning is we mentioned a third area of fraud detection, and I think there are a number of people probably in the room who are interested in that as an area. So I'm going to hand back to John to have a look at this one.
So what we often find with fraud detection, and there are perhaps more classic examples like credit card fraud and often sort of consumer financial transaction fraud, and increasingly there are more sophisticated and different types of fraud in the digital connected world in which we live, is that there's often a standard configuration before we start modelling, which is there are subject matter experts who are inspectors or investigators who are developing business rules, usually to go and look for that anomalous, potentially bad behaviour. So almost always the starting point is some level of subject matter expertise and a team actually working on the problem. Not always, but very often that's the case. Now, that gets harder to do, of course, as volumes increase, especially with digital data, and as the fraudsters get smarter, and there's a whole kind of cat and mouse game that goes on, obviously. The challenge we have with fraud detection is it's the needle in the haystack. So the example we gave earlier of predicting whether somebody churns or not, we're always starting from a reasonable percentage of the target that we're really interested in. So we might be looking at a 5% churn rate or a 2% conversion rate, but they're still reasonably large proportions of probably a larger record base that we can work against. Hopefully, fraud is the needle in the haystack, so that makes it harder to begin with. The other thing that makes it harder is we don't always have the evidence of bad behavior in the data. So part of this CRISP process that we talk about is to find that data that exists. If it exists, we can build a predictive model, because then we've got the target to aim at, and we can set the target in the time node just as we did earlier. So usually what you start with are anomaly detection techniques that are really looking for unusual behavior. Once you investigate those, this goes back to the team, and we're not really talking about replacing the experiential rules that come from the investigation team, we're really talking often about layering them on top, then you will get confirmed cases. And if this is part of a modelling process, then we should start to capture that data that perhaps was missing before or was missing in an accessible way to the modelling process. And we have confirmed cases, and we can start to do prediction. But the fact that it doesn't necessarily mean you stop doing this, because of course the behaviours that are driving this activity are often changing anyway. We wouldn't necessarily pick them up using predictive techniques. So if you start to think about what is it that we're doing when we're trying to identify in that first phase unusual behaviour, well, we can start to see it by plotting data just in 2 dimensions, maybe 3 dimensions, and look for those behaviours that lie outside the norm. That norm might be described as it is here by a nice straight line regression. The relationship that you would expect might be slightly more complex than that. The challenge, of course, we have is that often what constitutes unusual behaviour isn't just in one column in the database. It could be over multiple columns. It's a multivariate problem, rather like our churn problem earlier. So often what we need to get to are rules that encapsulate fraudulent, potentially fraudulent profiles that can be combinations of multiple fields and different thresholds within those fields that capture the potentially fraudulent behaviour. So I'm just going to flip to a very short demonstration this time, just to show you the difference in the way that we actually set up a fraud model versus the kind of predictive model that we looked at before. So I'm just going to go back to Modeler. I've actually got the stream already set up, so I'm not going to build this one from scratch. What we have here is, it's actually a relatively small data set. We had 100,000 records before. Typically we're processing thousands and thousands of records. And if I just show you what the type node does in this particular example. So we've got raw data, we've then created some new fields based upon subject matter expertise, which we think are particularly good detectors of fraud. So there is a kind of data preparation step here. We then set up the model, not with a target, because remember at this point we don't have any confirmed cases, but just as a set of inputs, and those are the inputs that we think are the signals, potential signals of fraud. The question is, how do you put them all together and identify anomalies across all of those dimensions? So the purpose of this anomaly algorithm is to do just that. So if I run it through, it's a lot like the raw mail example, where we're looking for groups of similar behaviour that we can target in order to sort of build our product out in a different way to meet those broad requirements. Here what we're saying is we know broad groups of general behaviour exist, but within those groups, which behaviours are unusual. So out of here we see, based upon the insurance claims that we looked at, the anomaly technique identifies 2 peer groups. These are really 2 segments of what it considers to be normal behaviour. So we could look at those rather as we did with the raw mail visitors and try and understand what those segments are about. But often what we're more directly interested in the fraud context is what are the unusual cases and why. So if I sort on one of the scores that comes out of the model, which is effectively an anomaly index. So this is an index, I'm going to sort it in reverse descending order, so we have the highest at the top, pop that out to the table. This is an index which effectively creates the suspect list. So it tells us, based upon those 2 peer groups, and there may be more than 2, there could be 4, 5, 10, the model works that out. These are top-down, the most suspicious records. So the most suspicious offices in this particular case when it comes to the level of insurance claims. Now, if I sort to the end, what you'll see is 2 things. First of all, it's difficult to see at the back, but this is the anomaly index. So you'll see it's a relative measure, but you get the sense that the first 2 records that have indices around 8 and 3.5, 3.4 are considerably higher than the others around them. So the hit list may be the top 10, it may be the top 100, maybe the top 5. Sometimes that's an operational question. You know, how many cases can we investigate? But certainly when you see much higher scores relative to the scores in the index, that makes a case more suspicious. And then what we also get is, across all those columns dimensions, what were the suspicious, what are the particular attributes that are the most suspicious? What is it that made that anomaly index as high as it was, effectively? And in this case, it's the accidents per population and the claims per population for record 1, and it's accidents and accident population density, question 2. And then, of course, we can do visualization, and we can just explore those relationships, where again, we can go back and look at 2 or 3 dimensions at a time. And if we just pick on the accidents per population figure, what you see is, just looking at kind of, you see the cases that are the most unusual. So that was one of the ones at the top, that's one of the other ones. Again, visually, you could probably get to some conclusion, but you'd have to draw a lot of visualizations to effectively cover the algorithm, I suppose.
Okay, great, thank you. So final area, just I thought we might finish off with, I hope what's a bit of fun really. So there was mention earlier on about why some of this now, and the fact that text is such a big part of data these days, unstructured data and that kind of thing. So I thought it might be worth just having a quick look at what we mean by text mining, what's involved, and then what are some of the things that you can do with it really. So you might also hear, I mean, it was mentioned, I think the term was used, natural language processing earlier, but it's basically very similar type of stuff. So why is text mining of any interest anyway? Well, for the reasons that were mentioned earlier, and also, I mean, one of the example I liked about the one in the mall, for example, about someone tweeting something. That's not some kind of structured transactional record that's ever gone anywhere. How do you start to pick up on some of those signals? Well, that is what some people, like some of the telecoms companies are doing. So the process overall tends to be taking in this text data sources. We'll look at an example of this. Some kind of enrichment process that takes place of that. So you can get these things called parsers, language parsers, they're language specific, and there are multiple different. There are potentially more than one type of parser per language. Some of those you can get in commercial packages. Equally, some language parsers are available for free as well, and are open source. So, and what happens is that they effectively add some structure to the text, and they'll recognise things like that's a noun, that's a verb, that's another noun. That noun is the subject of that verb, and then what happens is gradually, so per word and then per sentence structure, these things get appended as additional attributes of data. So it's gradually structure that's being added into these things, and then once we've got to that point, then we can process it in a similar way as if it was structured data. So I'll just go through an example. So kind of typical sources, I'm sure you're familiar with. It could be, so a very fruitful area for a lot of organisations, or a number of organisations, is actually their CRM system. People ring up and they want, if you imagine, you're a Vodafone or an EE or whatever, and they want something sorted out, that's fine. But then also very often they might have questions and queries, and there are notes that get made from the CRM system. So a number of companies process that text and use that as input into their product development cycle for new ideas. So it's again a formalised methodology for applying that. But some of the ones I mentioned here are things like social media channels. This is just to try and illustrate the text enrichment approach that I mentioned. Let's say so that might be the original message. So on someone's phone, so someone ranting about it. And then typically the kind of process the processing that happens is that, so there can be particular keywords that have got a particularly strong sentiment expected of them. But you can see over here, and so if there are particularly strong positive or negative sentiment, that can be highlighted, flagged as something for immediate attention. And what this is looking at down here is just again to try and illustrate is this is a particular part of speech tagger or parser. This is one that's freely available actually. So what it does is it works its way through the sentence structure, and then there are a particularly defined set of so VBG means verb, for example. So it effectively tags each word with what part of speech it is, and then builds up the structure that I mentioned. And then there's an element of processing to get rid of some of the junk that's in there, if you like, to get down to what the core message is. So that's the kind of thing that happens. We'll say what, because we said, well, this is the purpose of today is thinking about what difference can this make to you as an organisation. Well, the kind of things could be if you've got to the point where you've been able to extract in an automated way some of the essentials from that original message, then number one, there's a strong negative sentiment about it. If they're an important customer, you ought to be getting someone who's getting in touch with them. So there's a kind of the sort of complaint element to it. Number two, they've been complaining about the fact that it's a signal. So it's not a handset issue. It's not a billing issue. It's a network issue that they're highlighting. So you can build up these things. And it was associated in this case with a particular product. So further down the line, it might be that if it may be if you're a Vodafone, if you've got a particular issue with lots of complaints to do with network coverage for a particular handset, you might need to have a look at, is that handset working properly on your network, or so on and so on. So these are some of the kind of things that you can do just to try and illustrate. Let's skip on from that one. Final one in the same sort of vein was do you know what Hansard is? Have you heard of Hansard? Because it's publicly available. It's all the records of the speeches that take place in the House of Commons and House of Lords. It's freely available. I have to say, some of these government bodies, they don't necessarily make the data that easy for you to consume as a freedom of information request, but you can get it, and with a bit of work you can extract it from it. So we thought, well, why don't we, for a bit of fun, have a look at what are some of the kind of things that certain people might be talking about over a period of time. So what we did is we took, now again back to, you work on historical data, so perhaps some of the brand new S&P guys aren't the best people to pick because we don't really have any history to go off yet, very much. But we thought, well, we'll try and balance this with, so we like to look at Nicholas Soames, who's quite a right-wing Conservative MP, former Defence Secretary. What's he been talking about over time? And then Dennis Skinner, who I don't know if is he still in?
Yeah,
he is still in. Right, okay, it's a while to do, but what's he called? The Beast of Baldo.
Beast of Baldo.
Yeah, exactly. So a very long-standing kind of northern guy. So we had a look at. So we took as many of the speeches that they've given that we could come across. And then we just started to do some basic analysis on it, just looking at the particular terms, for example, that they're using. So this is looking at Nicholas Soames, which what we said. So he used the word country 72 times, probably for being kind of being patriotic and that kind of thing. Something else we thought was a bit more interesting though was occurred 40 times. What kind of things do you think that someone like Nicholas Soames might be talking about? What might be
Europe.
Sorry?
Europe.
Europe.
Yeah.
Okay, so some kind of international. Okay, so Europe. Any other ideas? Margaret Thatcher. Come back to that. Actually, that's very interesting. Any other guesses?
Immigration.
You're absolutely right. Look at that. That's a good guess. So immigration was his big thing. And then once you started to pick up on maybe what the particular hot topics of particular individual, good guess. then the kind of next step you can go to is have a look at, well, are those particular, okay, here they appear as words. Actually, because of the type of processing we've gone through, they've been extracted as a concept. So what we're really interested in is, are certain concepts being used together at high frequency or things like that. So this is a concept map looking at analysing Nicholas Soames's speeches from Hansard with immigration at the centre, because obviously you can then pick whatever concept you want to look at. And what are the other kind of things that he ends up talking about in connection with immigration at the highest frequency? The thicker the line, the higher the frequency, or the stronger the connection. And it's, if you can read that says it's social and society, so presumably societal impacts of immigration, and also defence, given he's a defence secretary, perhaps that's no big surprise. Just to keep the balance, so this was Dennis Skinner, who's kind of the opposite end of the spectrum. He had nothing to say on immigration at all, or virtually nothing. Yeah, okay, but one of the top.
Maggie?
So Maggie, okay, we've got a Maggie. Any other? Poor. Okay, so poverty and being poor. Housing. Because they're quite different topics, aren't they? They've got quite different. Jobs. Pits. The pits. So if you think back to, I have to guess for how long he's been in Parliament. Things like the miners' strikes, but so coal mining, that kind of thing. And again, just thinking about how does he use that kind of concept. The Maggie thing I was thinking, so the Tories and the pits get mentioned an awful lot. They're pretty high on the list. Over that Peter was, wasn't it? You mentioned that. And rowing about the pits, I think was another quite strong one. And also, and the fact that they need help. So anyway, so we then had a final look at the what was this one? Final the concept categories. Yeah, again, this is just kind of going on to the next stage. It's actually you can build up webs of concepts and do all sorts of them. But again, I just thought a bit of fun to end with. Worth having a look at. So text mining, growing area. Nicholas Soames is the last one. Dennis, natural resources, again back to pits for Dennis Skinner. Okay, look, that about covers all the kind of examples we were looking to cover with you in terms of the kind of modelling that we do. I hope that's been useful. If that's whet your appetite and you want to have a look at it and a discussion with us, we'd love to. No, don't leave details at the back, that's what it says, but actually, well, we know each other anyway, so just either give us a call or drop me a line or something if you'd like to have a conversation about anything. I hope you found that useful. I mean, have we done what we said we'd do on the tin, if you like, which was kind of big data and analytics, what practical difference it can make? So I'm mainly getting on. Okay, good. So thank you very much. And that concludes it. If you've got any questions, by all means, far away. Otherwise, thank you very much for coming, and we'll see you again soon. All right.